Right, so we're going to rewrite to the form of f of x equals a times b to the x plus k. So you'll notice that this is not in this form right now because we've got an x plus 1 in our exponent. So using our exponent rules, what I'm going to do is I'm going to rewrite this. I'm just going to bring down the 6, but I'm going to split up that 1/2 into two different bases, one with an exponent of x and one with an exponent of 1. So this is all going to be multiplication. This is going to be 1/2 raised to the x power times 1/2 raised to the 1 power, and then I'm going to bring down that plus 2. And then I'm going to go ahead and evaluate or simplify what I can. So I'm noticing that this 1/2 raised to the first power, anything raised to the first power is just itself. So I'm going to simplify that a little bit. So I'm going to bring down this 6, going to bring down this 1/2 raised to the x. And that's just telling me that 1/2 raised to the first power is just 1/2. And then I'm going to bring down that plus 2. So all of this stuff over here is being multiplied. So I have to be careful about my order of operations. So my multiplication property tells me that I can basically multiply in any order. So I'm going to pull this 1/2 raised to the x over to the side for a second, and I'm going to regroup and write this as 6 times 1/2. That 1/2 is this 1/2 right here, times 1/2 to the x plus 2. And then I'm going to go ahead and simplify. Since I know 6 and 1/2 are like terms, 6 times 1/2 is 3. I'm going to bring down this 1/2 to the x plus 2. So now this is in the form that we want it to be. Our a value is 3. This b value only has an x on it now, and then this is our plus k. So our function rewrite is f of x equals 3 times 1/2 raised to the x plus 2. So let's look at one more example. So let's say our function is now 2 times 3 to the x plus 2 minus 1. And again, it's not in the form that we want it to be in because this form only has an x in the exponent. Right now, we have an x plus 2. So I'm going to go ahead and do the same thing I did in the last example. I'm going to pull down that 2, and I'm going to rewrite this base of 3, one with an exponent of x and one with an exponent of positive 2. And again, that's all going to be multiplied together. So 3 to the x times 3 squared minus 1. I know I used parentheses over here in this last example. That was because that was a fraction. I didn't want to kind of get myself confused. You can use them over here if you want to, but you don't need to. And again, I'm going to regroup, or I'm going to actually simplify first because I can simplify that 3 to the power of 2. So this is going to be 2 times 3 to the x times 3 squared is 9 minus 1. And now I'm looking to say, all right, well, these are all multiplied together. I'm going to pull the 3 to the x over to the side, and I'm going to regroup to put my like terms next to each other. So I can multiply in any order. So 2 times 9 times 3 to the x. And again, I'm just kind of like carrying along that last term for the ride until the last step. And then I'm going to multiply my like terms here. 2 times 9 gives me 18 times 3 to the x minus 1. And that would mean that my function would be f of x equals 18 times 3 to the x minus 1. And again, this is in the form that we want it to be in because here's my a, here's my b to the x, and here's my k.